Ladies and gentlemen, thank you for attention. Today I want to presentation about simulation and dynamic system modeling in analytically support a rigid cylinder for vibration energy harvesting. My name is Subekti. I'm a student doctor program in ETH. Background of my research, the need for electrical energy in Indonesia continually increase. The electrical energy development is estimated to reach 7.1% every year with electrification ratio 16%. The number of power plants in Indonesia is nearly 9.5% and those use fossil energy. The National Energy Policy can or one the objective of CAN is to create the primary energy mix in 2025 by decreasing the natural oil consumption to be less than 20% and increasing the natural gas consumption to be more than 30%. You can to see is the picture, you can to see the government of Ministry of Energy and Mineral Research, Directorate of the General of New Energy and Energy Conservation set to the target to increase the energy source using the renewable energy by 23% in 2025 in Indonesia. You know about environmental friendly source of electrical energy generates in Indonesia. You can see as the micro hydro power plant, solar power plant, wind power plant, and biomass power plant. But I want to use the new concept, use the flow induction vibration to the renewable energy source in Indonesia. The effort creating alternative energy is currently being developed by utilizing flow induction vibration. The fluid used in the utilizing vibration due to flow can be in the form of fluid flow, in the form of gas, air, and water. Fluid, fluid flow and structure are the interactive system and their interaction are dynamics. The system is coupling system of the force action on the structure case by the fluid around it, the force of the fluid gas the structure to deforms. When the structure is deformed, it can change its orientation to the fluid flow so that the next time it's possible to change the fluid force. It's called the flow induction vibration. My focus in my research, I'm using the tall building and a lot of many airflow in the tall this building and essential the flow in ducting area by utility and airflow in ducted area and can use the new renewable energy source and I hope this can use the home energy can be developed in my research. This electrical support cylinder in my uh, we expand in the my case you can to see the flow and the kind moving in the cylinder in this the electric support cylinder and then I to change in use the wire inside to the cylinder and can I use the electrodynamics vibration energy harvesting in the beam with the point A the and then to wire to in point B. This is a dynamic model system in the my case. You can do to see in the this right side and left right side is the free vibration diagram on the system, but the right side is my simulation in the system. You can this is the moving left and right. If you give the force airflow and then to the free body diagram I can found about equation 1 for function time, and I found to equation 2, and this is a velocity flow, airflow, and this diameter of cylinder, this is length of the wire, and the CL is coefficient lift and time. But coefficient lift at time and this equation, this is a frequency South number. I am used the model in this model to frequency South number is 0.2 about generator generation system. Is this degree of freedom for vibration energy harvesting in point A and this point B. This force from YG in from beam, and then this function tension from time from a wire, and then I can do found equation 4, and then I know about equation 7. And the electric support rigid system simulation to determine the performance of a configuration system of an electrical support rigid cylinder system model that is installed with electrodynamic vibration energy harvesting in a model. The modeling that includes two aspects is needed. The first is system dynamics and the generator system. And simulation, I am used the wind velocity and cylinder of diameter. And variation for wind velocity is 10h3 millisecond, and for diameter is 118.15 millimeter. In this variation is my simulation in this conference. For the simulation, you can to see is dynamic system. In this dynamic system for electrical support rigid cylinder, and I can do variation to wind velocity and cylinder diameter in this system. And this simulation for the generator system, and these two system dynamic system, and this for the dynamic system, and this for electric system by system at point B, and this is point E. And then can I have the simulation in the system and can found the left set in the point E and right set is point B. You can see at velocity 3 millisecond, you can say is a power in watt in not a stable up down, but power to h velocity h millisecond and 10 millisecond is very stable. The same, the example for velocity h millisecond in stable near 3 times 10 to power minus 19 watt. But for the right side, you can see it's very clear about power generated in point B. The same to velocity 3 millisecond, you can to see the velocity after 118 seconds. The power is very slowly to up and increasing until 1.8 times 10 to power minus 70 watt. And then this is a decrease and increase again to the 4.5 times to 10 to power 7 to power minus 17 watt, and stable with the time after 600 seconds. But for the 8 and 10 millisecond, you can to see its velocity is very stable to the effect of velocity, and then in the power generate 2.B. To electrodynamic energy to affect a cylinder. The effect cylinder, you can show the high percent energy power give in left side to the large of the diameter. The grating power produced at some airflow velocity at diameter 100 milli and 510 millimeter. The power saw is very stable with a diameter of 18. The power produced fluctuative in the less stable. The less stable power requires addition equipment to stabilize the power produced. But for B, point B is the give diameter, the great power is graded at the same air velocity, and the diameter 10 milli and 510 milli is the power slow is very stable, and the case to the effect diameter A and B is the same, is very good, is 10 millimeter and to 5 millimeter. From the conclusion is my research is simulation using simulator and the elastically supported rigid cylinder system modular system that is installed with the electrodynamic vibration energy efficiency so that the airflow velocity and give the diameter grating affect the amount of power generated. Airflow rates to h mean meter per second. It shows that power increase rapid over time until it reaches 2 10 2 times 10 to power minus 17 watt. The rock give diameter is the grating. The power is generated at the same airflow velocity. At the diameter 115 milli, the power is so be very stable. While at the diameter 18, the power produced is fluctuative and less stable. The phenomena that occur due to place of electrodynamic vibration energies have been so that the place at point B is faster power than the place at power A. Thank you for attention, ladies and gentlemen.